Yeah, hi. So, good evening, everyone. So, we will start the class in some 5 minutes. So, if somebody wants to join, then they can join. By the time, we will wait for some 5 minutes.
Ma'am, I'm speak to one my mark, ma'am. Last week, fourth week assignment, 10 out of 9, ma'am. Ma'am,
So, hi everyone. Hope I'm audible to all of you. Am I audible?
Yes, ma'am. Good
Okay.
evening, ma'am.
Good evening. Okay. We will start the class. Before starting class, do you want to tell something or do you want to ask something regarding some topic or something? Okay.
Ma'am, our last class we are discuss the biological oxidation agent. Your answer is and also you tell NADPH, ma'am. And such the answer iron 3 plus is a correct answer, ma'am.
For what question? Means, can you tell me the question?
Which of the following is a significant biological oxidizing agent? The options are iron 3 plus, NAD plus, magnesium 2 plus, NADPH, ma'am.
Okay. So, we discussed that NADPH, right? But you are telling that NADPH is wrong, iron is correct answer.
Iron 3 plus is the correct answer,
So
ma'am.
how you are telling this means from where you read this?
Reducing, ma'am, oxidizing, ma'am. Ma'am, புரியல, ma'am.
Oh, can you read the question again? What which one of the following?
Biological oxidizing agent.
Okay. Okay, fine.
Ma'am, next question, ma'am.
Okay. So I will be sharing the slides. Okay. I will be giving some 5 seconds or some 30 seconds on each slide to think of the answer. So, because the questions, whatever this will be assignment number fourth. So, whatever we will be discussing, that already we have discussed in the earlier classes. So, I'm expecting the answer from you guys. So, please, I will be waiting for some 30 seconds. Please give me the answer for this question. So, moving to the first question. So, which of the following are example of iron sulfur proteins? So, first of all, what are iron sulfur proteins?
Methane or monooxygenase, ma'am.
Which of the following are examples of iron sulfur proteins? Carefully read the question. Like that, you will make the mistake in the exams also. When UGC people will give the exam now, then you will make the mistakes. Now the question is, which of the following is not an example of this? The question is not like that. The question is, which of the following are examples of iron sulfur proteins?
Rubidoxine.
Rubridoxin. What about risque protein and what about aconitis?
Ma'am?
What about option number third and fourth? Are they not iron sulfur proteins? You see, okay. So the question I will modify: which of the following is not an example of iron sulfur protein? Tell now.
Methane monooxygenase,
Okay,
ma'am.
this is correct. So now the question is opposite: which of the following is an example of iron sulfur protein? So option number one, three, and four. Rubridoxin, risque protein, and aconitis. All the three are example of iron sulfur protein. So what are iron sulfur proteins? Explain.
Rubridoxine, risky proteins, acantase.
Yeah, good. So these three are the iron sulfur proteins. So basically, iron sulfur proteins are the redox active proteins which are involved in various oxidizing and reducing processes in the human body. So in iron sulfur clusters, you if you will see, these are iron sulfur clusters. So the iron sulfur cluster, in iron sulfur cluster, if you will see, one is iron, one iron, two iron. So the name is 2Fe, and there is inorganic sulfur which is bridged between two iron. That S and S. On the basis of inorganic sulfur, we will name it as we will name in the basis of the number of inorganic sulfur. So here there are two number of inorganic sulfur. So we will give the name it as 2Fe2S. So this is adrenodoxin. And when we will remove the two cysteine residues of this protein Fe2S2 and replace it with histidine residue, then we will call it as risque protein. Okay, so all the three are the example of iron sulfur protein: rubridoxin, risque protein, and aconitase. Okay, so this you have to remember. So now the next question is, which of the following is a copper transport protein? Which of the following is a copper transport protein? Which of the yeah, people are there, right? In synthetic mode, hemoglobin. Okay, fine. So which of the following is a copper transport protein? Where is the girl which was telling? Can you unmute your mic and tell me the answer for this question? Hemoglobin is not a copper transport protein, okay? So that we know. Hemoglobin is not. This is an oxygen transport protein. And hemocyanin is also not. Plastocyanin, even this is in bold, even that also you are not able to tell. Ceruloplasmin is a protein which is responsible to transfer the copper. So ceruloplasmin is a copper transport protein. Okay, so moving to the next question. Which of the following are biological function of magnesium plus 2? Sorry.
Ma'am, osmotic balance, ma'am. Balance.
Osmotic balance. So, which of the following are biological functions? So, except osmotic balance, all are correct. Present in chlorophyll, that you know, right? Magnesium is helping in photosynthesis, activation of enzyme, information carrier. Osmotic sodium and potassium are involved in the osmotic balance. So, magnesium is present in chlorophyll and help in photosynthesis. It is helping in the activation of enzyme, and also it act as an information carrier. Okay. So now moving to the next question. This is very easy question. Most abundant element by atomic percent in human bodies.
Oxygen, ma'am.
Oxygen is present in the air. Oxygen is abundant in the air. Oxygen is 78% in the atmosphere. But they are asking about the human body. So most abundant element by atomic percent in human body. Sorry, not oxygen. Nitrogen is abundant. Nitrogen is present in the atmosphere, 78%. So, but we are asking about the atomic percent, maximum atomic percent of an element in the human body. Carbon. Carbon is the most abundant element which is present in the human body. Carbon. Okay, so carbon is the right answer. Okay. So, which of the following are examples of copper containing enzymes?
Carbonic anhydrates, ma'am.
What happened to all of you guys? Carbonic anhydrase is a zinc containing enzyme, right? Carboxypeptidase and carbonic anhydrase. This we discussed in the last class. Carbonic anhydrase is a zinc containing enzyme. This is a carbonic anhydrase in which zinc is present. Okay, so this is the urease in which nickel is present. This is catechol dioxygenase in which iron is present. And this is the copper containing enzyme which is galactose oxidase. You note down the structure of all these four enzymes. Now you should not miss this. First is zinc containing enzyme is carbonic anhydrase, second is urease, third is catechol dioxygenase, and fourth is galactose oxidase. So this is the copper containing enzyme. So note down the active site of all the four enzymes. Okay, so moving to the next question. The oxidation state of iron in mid human hemoglobin is. The oxidation state of iron in hemoglobin is.
3, ma'am.
Yeah,
Copper 3 plus.
yeah, iron is present in plus 3 oxidation state. Then only we will call it as methemoglobin. Whenever iron is present in plus 2 oxidation state, that time it is present so that it can bind to the oxygen. But when it will oxidize to plus 3 oxidation state, then we will call it as methemoglobin. So from here also you can.
Ma'am, previous question, please once again. I'll explain, ma'am.
Which question?
Copper enzyme சொன்னீங்களா ma'am?
This one you are telling.
Yes, ma'am. Answer, ma'am.
Answer is the question is copper containing enzyme we have to tell, right? Which of the following is a copper containing enzyme? So what about carbonic anhydrase? It is a zinc containing enzyme, right?
Yes, ma'am.
Okay, and urease, what about urease? This is the active site of urease in which metal is present? Nickel, right? So this is nickel containing enzyme. And if you will see catechol dioxygenase, in catechol dioxygenase iron is present, but in galactose oxidase copper is present. So they are asking about the example of copper containing enzymes. So galactose oxidase is an enzyme which contains copper in its active site. So from all the four enzymes, you can note down the. I was telling you to note down the active site of all the four enzymes, because the question now the next day they can ask you which of the following enzyme is a nickel containing enzyme. That you should know that urease is a nickel containing enzyme. That's why I was telling you to note down the active site of all the four enzymes.
Yes, ma'am.
Yeah. Okay. So the next question I told you, the oxidation state of iron in methemoglobin is plus 3. So you can see methemoglobin, which is also known as ferri hemoglobin. Ferri means iron in plus 3 oxidation state, is a type of hemoglobin that can't bind or carry oxygen to the tissues. It's a metalloprotein in which the iron in the heme group is in the ferric state instead of the ferrous state. Ferrous means plus 2, ferric means plus 3. And also it is a disorder that occurred when there is a higher normal amount of methemoglobin in the blood. This can cause by injury, exposure to drugs, chemicals or foods, or it can be a genetic defect. So basically, when the iron is present in plus 2 oxidation state in the hemoglobin, then we will call it as normal hemoglobin. But when it is present in the plus 3 oxidation state, we will call it as methemoglobin. That is ferry hemoglobin. Understood? Clear?
Yes, ma'am.
Okay. So moving to the next question. So a well-known naturally occurring organometallic compound is. This is the most simple question, and also this question they will ask in the UGC
B12
net.
coenzyme, ma'am.
Yes, they will ask this question in the UGC net also. Vitamin B12 coenzyme is the naturally occurring organometallic compound. This I explained in the last class also. The extent of pi electron conjugation and microcyclic ring of heme, coenzyme B12 and chlorophyll follows the order. You have to tell me the extent of pi electron conjugation in macrocyclic ring.
Yes, ma'am. Heme is a major, and second one chlorophyll, third one
Coenzyme.
coenzyme
Yes,
B12.
very good, very good, very good. So option A is the right option, right? So
Thank you, ma'am.
this I explained in the last class also. Heme is having porphyrin ring, which is having the maximum conjugation, then chlorine, which is having here the conjugation has broken, and from chlorine to chlorine, where from here also there is no conjugation and also conjugation has broken. So first is heme, then vitamin B12, and then chlorophyll. So option A is the right option. 1 is greater than 3 is greater than 2. So storage of iron in body is carried out by.
Ferritin,
Yes, right. Very good. So if I will ask, transport of iron in body is carried out by.
transferrin,
Yes. So transport of oxygen in body is carried out by. Transport of oxygen.
hemoglobin,
Yes. So storage of iron, ferritin. Transport of iron, transferrin. Storage, like transport of oxygen, that is hemoglobin. Very good. So this you should remember. So hemoglobin is a, yeah, we discussed. So hemoglobin is a heme containing globular protein present in the erythrocytes. Which of the following is the function of hemoglobin? So A, B, C, or D? Storage of oxygen or transport of oxygen or both?
transport of oxygen,
Yes, sir. Transport of oxygen. Yeah. So yeah, this was the assignment number 4, which I discussed at these 10 questions. So if you are having any doubt, you can ask me. I will explain the question again. So if you are having any doubt, you can ask. Otherwise, we will meet in the next class. You can leave the class if you are having no doubts. That assignment is over. So if no doubts are there, you can leave the class. We will meet in the next class then. Okay,
No doubt, ma'am.
no doubt, na. So okay. So if we will then okay, then bye bye. We will meet in the next class. You can leave the class.
Thank you, ma'am.
Okay.